see if they'd talk to me and willing to give me the time of day, essentially. I had pitched this idea to them of how we can introduce more tablet work to kids through 3D printing. The reason for that is because if you're a kid, or all of us were kids at one point, I would hope, that you pick up a pen and paper and you're able to draw. And as I was using Fusion, I started to realize, I'm like, well, Fusion in the sketch form really feels like you're just using pen and paper, so why not try to use both of those? So that's why we're here today. I had asked them if they would entertain us, and I'm glad we're here to see that. If you have a chance, some of these have Fusion locked in, so you can load up a picture and start drawing and connect the dots and create your own whatever you're making. So I am going to show you something that I made in Fusion, which is this guy right here, which is up there. And this is probably about 8 or 9 parts. It does disassemble, which is really cool. So if I travel with it, I can take the skull apart, put this in a bag, and take it with me. What I do like about this is that in Fusion and using the tablet, and you could do this with the mouse as well, I was able to measure everything out to run an entire PVC pipe through the middle. That way, not the entire thing is printed. And that's kind of what I've learned with cosplay and with 3D printing in general, is that you're able to use other parts to introduce to 3D printing. Rather than just print everything, you can also use whatever's available to you. So that way, when you're holding something like this, it's pretty solid. Whereas if it were printed, depending on the orientation, it may actually break on you depending on how heavy it is, because this is not very light, but due to that pipe in the middle, you're able to kind of have a little bit of leeway with it. So if you guys want to pick this up, feel free, check it out. I'll also have this at the Maker Fair, as well as a couple of other props, which I'm going to show you today. And granted, this is a dry run, and I will say that because I'm going to be introducing this to, how many of you have 3D printers? That's going to be the start of the Maker Fair one, because I assume not everyone has one. I assume most of you have played with them and or have one. But today I'm going to talk to you about how I use cosplay and artwork with 3D printing. So there we go. And what I want to talk to you guys about for anybody who is new is things that you can use, tools that you can use for cosplay or artwork as well. And things that I've used in the past are Fusion 360, Blender, and 123D. So a lot of these are free programs, which are great, but my favorite, my go-to is Fusion. And the biggest reason for that is because of how powerful the suit is for doing things that are very, very accurate to scale. I like accuracy. I like being able to print multiple parts, tear them down, and put them back together once they're printed. Because a lot of my parts are very big, I'm able to really use those parts to make them come together with Fusion. The other things that I have up here are printer types, filament types, and ease of use. If you guys want to talk about filament, talk to Keith over here at Protopasta. He has a ton of them you guys can talk to him about. From everything from PLA, Max as well. What's up?
I brought a shipment of PLA, ABS, and PETG from a very dependable, cheap supplier.
So if you guys are looking for extra filament, Max does have some. But I will say, all of the props I've ever made so far have been either PETG or PLA. The biggest reason for that is because of the toxic nature of ABS, and my printer is about 5 feet away from me, and it's not vented. It's just in a closet. So I print with those two, and I'm able to make things just like this. Now, when I talk about 3D printing and about cosplay, this piece is actually all foam. This is the armor work that I had done to go along with this prop that I had made. The reason why I got into 3D printing, to be honest, is because I'm a chef by profession. I work too much. There's too many hours spent in the kitchen. So I wanted to be able to cosplay without really spending the time to do it. So I got into 3D printing, and I'm like, well, how can I cosplay and be at the hotel all freaking day? That's where 3D printing came into my life, where I could start a print and leave, come back, take a piece off, start the next piece, and continue that process while I'm at work. It was a way for me to be a little bit more efficient, and I thought, okay, well, if I'm efficient in the kitchen, why can't I be efficient this way?
Passive making.
Exactly, it's passive making. And a lot of people do this with 3D printing now by essentially having farms where they're able to print multiple parts at one time and sell them. I know Maz does that as well, where she runs an Etsy shop. And how many printers do you have now going?
I literally have 4.
Yeah, then I mean, they're constantly running though, and that's the thing, is you're able to make product or make artwork and walk away, which most of the time, until you come back to a rat's nest and everything melted and everything's on fire. But as far as what you're looking at for, let's say you're making a costume, What you really want to look at are timing. How long do you have before the event? I always mess this up. Oh, I have 6 months? That's fine. It's never enough time. Always double your time. You have to look at those things. Resources. So what tools do you have that you can actually use? We have 3D printers. We have resin printers if you're doing smaller parts. But you also have things like foam. The biggest thing is being able to introduce these parts into your 3D printing. I say that because I've learned from experience that as amazing as 3D printing is, when you print a 7-foot axe, you don't want to print a handle. That's going to cause a catastrophe. It's going to cause someone to break it at the show, run a PVC pipe through it, reinforce it with a print, and call it a day. How much can we build this printed and how much can you make by hand? And that goes back to the previous message, is that you don't have to print everything. And I know we're here for 3D printing, but you don't have to print everything when it comes to artwork or when it comes to just making in general. You have to consider, do you want to 3D print a necklace where you can take a beautifully polished rock and insert it into there? Now you have this necklace with a beautiful polished gem instead of printing the entire thing. Consider those when you're looking at making any cosplay artwork or printing in general. This is that 7-foot axe I was talking about. That's how many pieces I had to print. I designed that in Fusion. It was a ridiculous print. I did that for a friend of mine for, it was the last convention in Seattle. I think it was PAX or something like that. I forget the one. But I had printed this in PETG. The reason for that is because I wanted it to be very durable, but also be very light. And PETG allowed me to do that, considering some warping issues that I had. But when you print to this scale, you're allowed to do things with PETG that you can't necessarily do with PLA without worrying about how fragile it can be. With this, I was able to print it in multiple pieces, glue it together with a little bit of 2-part epoxy, sand everything down, which PETG does sand down very nicely. PLA melts, for those of you who are unaware, which you will make mistakes doing. But that axe in particular was about whatever how many pieces that is, and I ran a PVC pipe through the middle of it. So when I designed this area right there, that little round piece actually has an insert for a 22mm PVC pipe. So he's actually able to remove that pipe and store it however he wants. Those are things to consider when you're really making anything. And to me, forgetting to do things like that is actually going to limit how creative you can be in a 3D printing space. So never just rely on your printer. Always consider what you're going to run through it. Then I had this problem. This is what I dubbed the Dawnbreaker problem. I had approached Wacom, and I told them I would build them a prop using just a tablet. That was a learning curve. They had supplied me with a 16-inch Cintiq, which is a phenomenal tablet, and that tablet also came with a 3D pen, which works like a 3D mouse. This is a 5.5-foot sword I had to create. I only used PLA, and I only used plastic. There's no metal running through it, there's no pipes running through it, there's no wood running through it, nothing. So as I decided to design this, I had to first think about how big it's going to be, 5.5 feet. How heavy is that going to be? My printing program, I use Cura, is very much off all the time with guessing how much it's going to weigh. So as I started to progress through this, the final print came out to about 4 pounds. And that's doing things, trying to trick it, trying to say, can we get away with 10% infill here, 30% here for the handle, and being able to create strength while keeping it as light as possible. Because if any of you have ever been to a convention of any kind, walking around with a prop all day sucks. But, it does suck, but you're doing it because you love the craft. So, how do we approach this problem? This is a sketch I had done to kind of get myself hyped up. I had done this to kind of create blueprints for myself. So I had to find a reference from the game League of Legends. I used fan art. ArtStation is amazing for that. I used Google, and I pulled direct files from the video game itself. That way I can look at them in Blender. When you're pulling files from something, you're allowed to manipulate them however you want. This will really give you a better idea of how your final product is going to look. If you don't have access to that, if you only have, let's say, one of those images up on the wall, you can still manipulate those, just like Maz did with the statues that she brought today. She only had a picture, and she was still able to create those 3D scale-ups. I, however, was fortunate enough to be able to rip files straight out of the game and use those as my template. Now, you talk about sizing it up. This prop, in particular, for the character's 5 feet tall. I'm 5'10". So I scaled this up to my size, so it wouldn't look like a little dinky pickaxe. So instead I scaled this up so it looks a little bit nicer in my hand. So knowing that this character is as tall as she is, I had to make that sword 5.5 feet. And it sucks. But I wanted to do it. It was a challenge to myself. My medium for this was PLA, all the way through. The reason why I didn't go with PETG is because my printer likes to warp it, and I suck at printing PETG, so we'll have to talk later. So I used PLA. This is what it looks like in AutoCAD. And that was the original image that I had pulled. I based everything off of that top image. This was my final design at the bottom. And when you're really looking at this, I started to think, okay, how much is it going to actually weigh? It's going to weigh quite a bit. 4 to 5 pounds at a convention where you're carrying around this giant thing does add up over the days. When you're looking at the breakpoints, it's kind of, I don't know if it's a little hard to see. You have multiple pieces here. Granted, I scaled this again to my printer size. My printer prints like 10 inches high. So printing a 5-foot sword took multiple prints. But as you're going through it, you can see that there are actually pegs inserted into all of these parts. As you're going through, all of these pegs are different lengths, different sizes. All of them are infilled to 100%. So they are very, very strong, but there's still a ton of pieces that you're gonna have to super glue together. So when you're looking at this, always consider if you're printing a big prop, how are you gonna actually glue it together? How are you gonna bring it together? You could, if you're doing ABS, you can do things like slurry. But if you're doing PLA, super glue works the best, absolute best.
I've found there's some good solvents as well.
Solvents
Acrylic
do
solvents.
After like acetone and things like that. I don't know if I can show the video. Can I? That's a laser pointer.
Probably need to grab another.
Oh, it's probably gonna ask me for. It's gonna pull it out of this though. Oh no, go back. That's fine. Well, there was a video of me actually designing the entire thing. So I had recorded the entire process of me designing this by hand. So just imagine me just doing this real quick. Right? When I was designing this, I had to look at the durability, points of stress, the glue I was going to use, the custom pegs and dowels, no metal or wood inserts. So when you're talking about stress points, if you're holding a sword, stress point is at the hilt and at the handle. So now, when you're looking at the entire blade, that's what it looks like in pieces. When you're doing the entire blade, you're looking at pieces. But with this one in particular, because I like to kill myself at night, that circle is all of the stress. This is not a solid plate, right? So when you're looking at this, there's this huge 7-inch circle, this gap in the middle that most of your stress is going to. So when I'm constantly thinking about how I'm going to print this, looking at from the hilt to the tip of the blade, all of those blade pieces are 5% infill. That's to keep it as light as possible. The rest of it is between 10 and 50% infill. When you look at those kinds of things, you're able to actually manipulate the infill to give it more structure, give it more rigidity. And we're just making a sword. All those things have to come to mind when you're starting to print big things. This is what it looks like before any pegs, any glue, anything was involved at this point. I just kind of looked at it and thought, why am I doing this to myself? This is when I started to glue it together. It took multiple pieces, multiple days of getting this thing to finally start to come together. And it was clean for the most part. There were gaps, which we'll address later. But when you're looking at PLA, like I had mentioned, super glue is your best friend. Always wear a respirator if you're doing it, but super glue for PLA is your best friend when you're bringing even these bigger parts together. Almost nothing else works just as good as that. If you're using ABS, you can make ABS glue and ABS slurry. ABS glue and ABS slurry are basically ABS melted down in different ways and different strengths. Those work the best for ABS. For doing seam work or anything like that, you can also use those to remelt the ABS. PLA doesn't play as well with melting and heat, so I would say avoid that if possible. And I'll show you how I started to gap fill with PLA. I used a 3D pen. Picked it up on Amazon for like 25 bucks. It worked fairly well, and I had some gaps in my original design because some of the pegs didn't match up perfectly. There was 1 or 2 millimeters where it didn't allow it to come together, so instead I ground out a little bit more of it and allowed myself to use the 3D pen to gap fill. This gave it strength, it allowed me to resand it, and allowed me to fill the print. So that way it wasn't wobbling around. Reason for that is because you're gonna start primering it, and you're start sanding it, and you're gonna start adding gap filler. Gap filler sucks to work with for one reason with 3D prints, because if you do it with foam, most of the time it's not gonna crack on you. With a 3D print of this size, each one of these gaps and lines here are points of contention. As soon as you pick up that blade, if there's any movement in any of those parts, all of your paint's gonna crack. And you don't want that. It's just, you're like, you know it's there. Someone's standing like 10 feet away, they don't notice the crack, they come, like, just stay a few feet back. Don't look at the imperfections in this. And that's how we pick. But for filling all of these, XTC 3D works really well. It's a little bit expensive, I will say, but it works really well if you guys are looking to smooth out your prints. But I just use automotive high build primer. It'll help you get a nice finish to anything that you really make. This is what it looks like after one pass of primer filler and one pass of gap filler. And it's kind of harsh. I think I got a laser right. Yeah. So right there, you can see some of the green putty that I use. This is automotive putty, very toxic. Always wear a mask. It's all in these areas to make sure that I don't really have any seam work. This is the first pass of primer filler. This is the first pass of putty filler. I do 5 to 6 passes. So you can imagine how long it takes to do something this big. This is the second pass, and I was going to bring this today. I really, really wanted to, but as I was coming up to picking this thing up, I did notice in this area here, we had a crack. I don't like those. They're not fun to play with, and they're harder to fix on a 3D print. So what did I have to do? Cracks in the primer filler. The reason for that crack was because there was a small gap that I wasn't able to fix. But you can use paintable silicone. Literally the stuff that you seal your sinks with. And that's because it's more pliable. It has a little bit of forgiveness if it moves. It won't allow it to crack again. So if you're looking to fill in a gap with a 3D print, consider a couple of things like that. I know a lot of people don't really print big projects here, but if you continue to do multiple piece projects, consider doing things like this. And unfortunately, because the print is not done, and I still have to spend another 50 hours painting it, we're going to be looking at the final sanding, the masking and paint, the details, and the sealers you're going to need at the Maker Faire. I will say this project has been extremely fun, and I was able to utilize the tablet in very cool ways. So if you guys haven't tried them, I will say give them a shot. But I will open it to questions now, and I will say, if you guys are looking to print something massive, don't print the whole thing. Consider what else you can use from your local Home Depot, from Lowe's, from the thrift shop, whatever you got, because that's going to make it better than just fully 3D printing it until those things get better. We got a couple of questions. Anybody have any questions? I know you had a question earlier. What do you got?
You said as a design goal, no metal and wood. Was that purely for weight, or was there some other design?
Good question. Metal detectors.
I thought that might be the case.
Yeah, if you go to, so Comic-Cons are very good about security now, which is great. This piece itself is all plastic as well because there's PVC. I could have ran PVC through the middle of most of those parts and just have plastic, but I wanted to accomplish the only challenge of making sure that I printed all of it. So everything in that build will be plastic, but for convention reasons, having just plastic raises far fewer questions, because my wife tried to walk in with this jacket that had studs everywhere, and they wanded her for 20 minutes to make sure she wasn't carrying anything. Max.
Okay, to follow up on that, do you mind holding up that blaster? That is made with Protopasta stainless steel PLA.
Yes.
So speaking of metal detectors, that plastic would probably set
It
off
would
metal
set it off,
detectors
because what's
at
the
the con.
percentage on that?
60%.
60%. Realistically, you're going to set off any metal detector with a lot of those, and it just causes a little bit less friction when you're trying to get into a big convention or a big, big event like that. But it was really a challenge to see how much weight and how much stress I could put on a bigger print without those other parts. And I kind of do that, where I go back and forth. I've found over the course of the past couple of years of building these bigger props, you're always better off using another part. Using a PVC pipe, using a metal rod, using a wood dowel of some kind. just because no matter what, that 3D print is going to be more fragile with printed rods than it would be with a pressed PVC pipe. A good question. Mass versus
What if you assembled your part with like stainless steel bolts? Do you get in trouble for that?
That is, if you mean actually like bolting everything together.
Yeah, because that's my kind of current position.
I would say I have brought in, I had a giant prop that I brought in last year for Rose City, and that was partially 3D printed, but I had a ton of nuts and bolts and springs and everything like that. They don't really have any issue with it. It just takes longer to get through security lines kind of thing. Nowadays, it is a little more difficult because of just issues they've had with security. But if you have a way of securing things, like with this sword, I personally don't think I could use anything to bolt together in a way that would make it look really clean. So instead, I have to basically secure it with glue and Bondo and sealers from the inside. But if you have a way of bringing it together with nuts and bolts, just paint it. People bring things like that in all the time. I mean, for God's sakes, they weapon check my wife's Harry Potter wand for Rose City. So, you know, if they're gonna want to check your prop, they're going to. But I feel like you would be okay. A lot of the time, they'll say, is it a bludgeoning weapon? So that giant sword, if I were to drop it, it would probably break in quite a few pieces. So if I were to bludgeon someone with it, I get one good hit and then it breaks. So there's that too.
So like that blaster would pretty obviously not be a real gun, and then they just let you buy.
Correct. That they wouldn't consider that like a bludgeon.
It might set off the alarm.
Like
and
if
then
this
it
were
tossed me,
solid, if this were solid, they wouldn't let you bring this in. Yeah, that's
It's
something.
still questionable.
Yeah. And then you had a question as well?
Yeah, so you mentioned the pegs. Were the pegs all 3D printed as well?
Yes. So the pegs were something that I'd been playing around with for a while, and it's the simplest thing. But if I don't know if we can go back to a very early picture. This one. So each of those peg slots, some of them are different depths. And what I had done is basically just cut out 10 millimeter pegs for the hole, for the female. All of the male adapters were 9.2 millimeter because that's kind of the tolerance that I found that my printer worked really well with. So all of those were 9.2 millimeter in width to go into the 10 millimeter slot, and all of them were 100% infill. So if you were to take one off the printer and try to break it by hand, you pretty much couldn't.
So do you print them in layers going up in the diameter?
I did. So if I was
Interesting.
printing it horizontal, it would have probably been stronger. And after I glued everything, I realized that, and I was like, huh, that was stupid.
I tried some pegs like that before and found that they aren't very strong because of the layer adhesion between
Yeah,
the layers.
My workaround was making sure you're at that 100% infill. I slow down my prints a little bit to make sure that it kind of mushes together a bit more. I still couldn't break them by hand, but I know that impact will break them. And that has a lot to do with the weight from the actual prop. If you were to just drop those pegs or try to break it by hand, they wouldn't break. But yes, printing them to where you're making the lines go the other way are a lot better.
On the pegs,
Yes.
as far as printing it this way, since you have to glue it into the spot anyways, why not make it 2 pegs where it's half and half, and you're slicing them long ways so that it prints easily, because you're only printing a half circle.
Yeah.
You got 2 half circles, you shove them in there, you've got glue along the seam as well as inside each end then.
Yeah, because you could do exactly that. Doing stuff like that would work. The only thing you just probably have to rescale it a little bit to understand that there's a little bit of glue
Right.
because of how close the tolerances are. So if you are splitting pegs, which would work really nicely, bring it down to 0.1 millimeter or something like that, and you'd be able to get it. Go ahead.
Nice, if you could it's a PLA, right? So you could heat treat the pegs, just the pegs.
The pegs, possibly you could melt them in place.
Work.
Right, so
But I'm saying the pegs themselves. Is all.
exactly. So you could heat treat the pegs a little bit to basically melt them together. The problem that I found is because of how deep I wanted the pegs to go into the print, if I tried to get heat into the female slot as well as the peg, I was going to warp it, no matter what.
The peg itself.
The peg itself, yes, to make it. But the other problem is that if your tolerances are too tight and you heat up the peg and it is PLA, the PLA expands. Then you actually can't get it in the peg. So then your tolerances change again. Because I did try that. It's like, I'm going to heat it up and went, and just smushed up against the walls and it wouldn't move forward. Yeah.
There's a poster, you need it, and it helps with all bond.
One thing I think, now that I'm thinking about it, may work is if you actually melted PLA directly into it to keep it hot, and then smash the peg into that. That would probably, and then throw some glue in there just for extra measurements.
This just makes me think of steel. Have you tried freezing the peg to shrink it before you put it in the hole? Because when it heats back up, it would expand.
You could, but then why not just print the tolerance correctly?
Well, you could use the same tolerance and shrink it and then have it expand into the slot.
You could, but then what if you run into the issue of actually expanding? And since those are only 5% infills, you have a chance of cracking things very easily.
So that's why.
Yeah.
You mentioned trying to split the peg and do kind of top and bottom. Did you consider that for the blade of maybe taking, the top half of this and overlap the bottom half of this, so you'd glue them this way?
And glue them together. So if I were to do that, it would be a lot more pieces. And that's kind of the issue. So these are single pieces, and my printer can print that high. My printer can't print that wide. So I kind of thought, what's the most effective way of printing this thing? And if I were to print them flat, I would have to print, obviously, multiple pieces, more pieces than it is right now. And if you print more pieces, then you're creating more problems in the future. Because if this were split here, what's going to happen is now I have to join these two pieces together with more pegs, and then I still have to join those together.
Unless you offset the joints.
Okay, sorry.
Unless you offset the joints, so that you count.
Yeah, I was gonna suggest something like that, but on the, so you couldn't print that wide, what about on the diagonal?
I haven't tried, like even my printer bed is only, granted, if it were a bigger bed, I would absolutely print flat, because then your lines are a lot stronger as well. That's another benefit.
About making it like Legos, where they fit into each other.
Yeah, I
and
considered that.
they overlap.
Yeah, I considered that doing, I guess it's kind of like a dovetail,
Yeah.
where you could print, one of these pieces to protrude and then you have something else to like lock in. The hard part is this piece would print fine. I think a couple of the other pieces would print fine. So some of them could dovetail into each other. It would just make it more difficult for a couple of the other ones. Like this one, I printed up. I wouldn't be able to print the dovetails here. So if I had them, protrude from this side, I wouldn't be able to have them from this side. So to me, doing the peg work is a little bit easier, to be honest, rather than re-engineering the entire thing. But I have done that, and it works really well.
Maybe they could, the pegs could go into it through the sides then.
Not on lengthwise.
So you could have, and then have them overlap like this.
Right. Oh, I see what you're saying. So that way they're actually almost touching.
Yeah, so it's like cut it in half lengthwise, and then have some pieces overlap other pieces.
And then offset it. Yeah, that would absolutely work.
Maybe using biscuits.
What is it?
Biscuits.
Biscuits?
Yeah, this is just a woodwork.
Squares.
I'm like, we throw
Basically, you put instead of using, it'd actually be even stronger because instead of using posts,
Yeah.
you basically create these flat, they're called biscuits in woodworking. Like they look like little ovals.
Oh, I
It's
see.
like little
They're
islands.
just a little more shallow.
They're super thin. You make them maybe like 2 millimeters thick, and then you can slide them in like they're just like dowel pins or footballs.
Yeah, it's similar to a dovetail. That would actually be. The other thing is when you're kind of changing up the layers, it's not really meant also to just match up the parts for me. It's to create strength too. Yeah, because it's so thin.
Or you could thread your holes and put the pin or whatever all the way like through holes.
Yeah.
And then you can 3D print your own screws to lock it.
To lock it in place.
Lock
Yeah, I considered doing the threads as well. The only thing that I would have been worried about is actually matching them up because I'm still very much new. So threading them just didn't make as much sense to me. But if I were to come back onto this would have probably still been a single rod all the way through. If I didn't want to 3D print this, I would have just ran a rod all the way through it, called it a day.
Just hang on just a second.
Yeah.
I love the ideas. This is presentation practice for Paul also.
So why don't we throw a few questions at him that he might expect from a less technical audience and see how he responds to those.
That's 3D printing.
What made you choose this sword?
Because I really liked the character design at the time. I was a big fan.
How long did you spend on this?
It's about 60 hours of design time.
So piece of feedback on that first answer. Can you name the character, where they're from, and why the sword was important for the people who don't know? Because I have no idea.
Okay, so this character, her name is Riven. She is from League of Legends, and I was heavily into the game at the time. But I saw the artwork and fell in love with the artwork. And that's kind of how a lot of my builds come. It's like, oh, I really like this artwork. Let's make something from it. And now with 3D printing, you can do that, which is really cool, without sending it out to someone else or buying a cheaper version of whatever you're trying to make. Now you can say, I like this artwork. Let's bring it to life.
So as a speaker, these little stories these are cool. So that's how
That really connects you to your audience. When you can tell that story and they can make that connection between you and the...
Yeah, that's honestly why I do. Like this one, I like the character when she debuted. I really wanted her weapon. Decided to make it. That's really what it comes down to. And then, what was your question?
How long did you print on these?
I believe it was 150 hours of print time on my printer. My print bed, and that is 120 by 120 by 240. Oh, okay.
What kind of printer is it, though?
Yeah.
It's a Robo R2. Yeah, no by millimeters. I'm sorry, millimeters. I wish it was centimeters. One shot to do it.
Are you going to get close to that coloring up there? And if so,
Yes.
how?
So once it's done, it'll be this beautiful sky blue and gold. And then you'll see the little diamond here, which is going to be really cool. I'm going to print a piece of clear PET G as a rod to run through it to look like it's free floating. So that'll be really nice on the end of it. And then hopefully it can fit a light because it's supposed to glow. We don't know about that yet. Maybe a little LED or something. So.
What kind of paint do you plan to use?
I use Rust-Oleum 2X paint primer because it's cheap, but it's also very thick, and it lays onto prints really well, especially after primer. Plus, you can get it at Home Depot for $4 or $5.
How much did you pay for your printer and where did you get it?
Ooh, I paid $1,100 for it, 3 years on Kickstarter. And that was because a friend of mine had the Robo R1. He said, Paul, you should buy a 3D printer. You make enough money to buy these things at the time. And so I just went for it, and I was like, well, I can print little daggers and whatever the case is. And once I got up here, now I'm printing things like this. But I will say there are better options.
That's a lot of money. Is there anything else you can do?
Yeah, absolutely. So if we go back to this one. So when you look at smaller printers, this, for instance, is the Matterhunter's Pulse. That's about $650. You can get printers now as low as, I think, $200 according to our brochure that we have out. $150 for a 3D printer. So if you're looking for a 3D printer, pick up one of our brochures. We'll take care of you.
If I wanted to make, if you wanted to do this again, say maybe get a more optimal printer, what would you choose? Either the R2, but what would?
Ooh, if I were looking for a printer today, I would think for a project like that, if you're looking to print bigger, something with a bigger print bed do exist. I would contact my friend Max over here. He uses CR10s, which are a lot bigger. They do require
I use heavily modified CR10s. I don't necessarily recommend that you try to do this on a stock CR10 machine.
Yes. I would say if you're looking for something that's intended to play, something like the Pulse works really well.
Paul has pretty good luck gluing parts together, so I think you'd have more luck with a high detailed machine than trying to buy something giant.
So
And trust
you got for you on this one. Use the group. If someone asks that question, direct them into the into the auditorium. Say, this is what I think, but you can see a lot more of these in action in the auditorium, because that way, otherwise, people will get into this bouncing around. I have this, I have that.
Yeah, absolutely.
What glue did you use for PET G?
For PET G, I use either 2-part epoxy or I make a slurry for those two. So like we were talking about with or you can use acetone, which also works, but highly toxic.
Yeah.
So use parental supervision, I will say. But slurries, melt them together actually works the best by fusing them with more PET G, works a lot better.
And you make the slurry using acetone and
And PET G. And be able to just mix them together and brush it on, and it'll glue the 2 parts together.
So a little bit of feedback about the printers as well. Judging your audience, if they really are beginners, you might want to point out that the price points can be as low as $150 or $200 to get into a good entry-level printer. And then once you start there, you're in trouble because you're going to buy another, you know. But you know, let them know that I think is kind of a good entry point to keep in mind.
Now that I know, I would have never bought my printer at that price. But that was 3 years ago. So a lot has changed since then.
I always say the $150 printer is worth that much in education alone.
Oh yeah.
If you never really get good results, you'll learn about 3D printing.
Absolutely.
For $150. It's worth $150.
Okay, you know, I've got.
Any other questions, guys? Before I wrap it up?
No, more technical question. What kind of infill did you use?
For most of the parts were 10% infill, and I used an actual, I used triangles through my infills. And I found from just doing research that triangles were supposed to be the strongest infill. So I used that versus like a honeycomb or squares or lines. That was just something that I've never tried before. And I found you can just do a plugin with Cura, and it has that, which is really good.
And then another quick technical question. When you were looking at doing the design, did you consider the layer direction in relation to finishing afterwards? Is one layer direction easier to finish than another?
Yes, that has a lot to do with if I print everything the same direction and I glue everything together, I just take a big old sand pad and just sand the whole thing down. Versus if I do different layer directions, I do have to be more conscious of the way I'm sanding. Because it is PLA, PLA melts when you sand too hard. So if you have different lines melting in different ways, it does look very weird. So printing them all one direction is a lot better than printing different line work. So if you guys are printing big things, yeah.
Palm sanders are fun. They are a little dangerous. You have to keep constant motion because, as you say, PLA will melt. But if you can keep that constant motion and lightly sand and let it cool off and sand, your hand will go numb, but you don't have to spend all day sanding.
Yeah. If you guys do have the ability to, and you're doing things like this, print an ABS. It just sands so much better. It's like, go buy a Nerf gun and take a sanding drum to it, and it actually sands for the most part. Whereas a PLA does melt at a lower temperature. That's why you get those effects.
And you can look at a freshly sanded part right there if you're interested. Yeah. That's dust all over it.
That's
Well, I would have to bring up that the matte fiber photoplasty, you can also sand it very easily and carve it.
Yeah.
So it's not only ABS.
Yes, that is right, because PETG I also have sanded very well. So PETG sands very well as well.
Does it carve very well though?
No, it kind of acts closer to PLA in that regard. But it does, you can take a sanding drum to it, no problem, and sand away. Anything else, guys? Before we close up for the day, I give it back to Shashi.
Have you completed that sword yet?
It's still drying. No, it'll be ready at the Maker Faire. So if you guys do want to see it, and you guys are going to be there, I'll have it on display at the Maker Faire. Love to have you guys come by, come say what's up. Throw tomatoes out on stage, whatever you want to do. It'll be a fun time. Thanks, guys. Appreciate it.